All right, now we're going to talk about special right triangles. So here we can see we have an isosceles triangle. And we remember from when we talked about isosceles triangles, that these angles opposite the congruent sides are also congruent. And since we have a right angle, they have to add up to 90 degrees. So we have a 45, 45, 90-degree triangle. Which is an isosceles triangle. That we can form by cutting a square diagonally. So that's a 45-40. Why do we care? Well, in a 45-45-90 triangle, the hypotenuse is radical 2 times as long as each leg. So each leg is n, so the hypotenuse is going to be n radical 2. Well, how do I know that? Well, we have, if we put it into the Pythagorean theorem, we have n squared plus n squared is going to equal our c squared. So n squared plus n squared is 2n squared equals our hypotenuse squared. Take the square root of both sides. So we have ABC here. And then n, square root of n comes out, and we're left with radical 2 equals c. So we know that if we just multiply each leg by radical 2, we're going to get the hypotenuse in an isosceles right triangle, or 45-45-90, whichever it is that we want to call it. So let's look at some examples. Well, here we have a 45, 45-90, because the two acute angles have to add up to 90. We have one leg that's 8, so we're going to have another leg that's 8. So x is going to equal 8 times radical 2. Easy enough. But what about when we know the hypotenuse? Well, if we're going this way, we're going to multiply by radical 2. So going this way, we got to divide by radical 2. So x is going to equal 5 radical 2 divided by radical 2. In this case, the radicals cancel, and our answer is 5. Now, if it doesn't always work out that way, that's okay, but we know we can't leave the radical in the denominator, so we're going to multiply by radical 2 over radical 2, because any number over itself is 1. We don't change the formula, and we get that radical out of the denominator. So that's our 45-45-90. Now let's look at our 30-60-90 triangle. So in a 30-60-90 triangle, the hypotenuse is twice as long as the shorter leg. So if we think about it, we're going to have a hypotenuse, we're going to have a shorter leg, and we're going to have a longer leg in a 30-60-90. We're in a 45-45-90. We just have legs, because they're the same, and the hypotenuse. So the hypotenuse is 2 times the shorter leg, and the longer leg is radical 3 times as long as the shorter leg. So the hypotenuse equals the shorter leg times 2, and the longer leg is going to equal the shorter leg times radical 3. And we're just going to keep doing this over and over. And if we get something that's not the short leg, we got to find the short leg, because both the hypotenuse and the long leg, we need the short leg to be able to find them. So once again, let's do a couple examples. So we have a 30, 60, 90. They gave us the long leg. This is the short leg over here. Here's the hypotenuse. So we got to go from the long leg to the short leg, and the longer leg is the shorter leg divided by radical 3. So to go from the long leg to the short leg, we got to take and divide by radical 3. We can't leave radical 3 in the denominator. So we're going to multiply this by radical 3 over radical 3, because, as we all remember from 4th grade math, when we multiply fractions, we go straight across. And radical 3 times radical 3 is radical 9. 9 times radical 3 is 9 radical 3. Radical 9 is 3. 9 radical 3 is still 9 radical 3. But 3 and 9 cancel. We can reduce this to 3 radical 3. When we multiply radicals and numbers and they're multiplied or divide them, it's inside with inside, outside with outside. That's how we know we're doing it right. And that we're keeping our radicals where they belong. And remember, 3 radical 3 is an exact number. If I put it in my calculator and come out with 1.7 times 3, I'm getting an estimate. So now we have to find y. Well, we know that x, the short leg, is 3 radical 3. And the hypotenuse is the shorter leg times 2. So I got 3 radical 3 times 2, which is going to equal 6 radical 3, inside with inside, outside with outside. And again, it doesn't matter the order that we multiply in, so that's why that works. Let's do another example. All right, so got a 30, 60, 90 triangle. They gave us the hypotenuse. We've got to find the short leg and the long leg. I need the short leg to find the long leg, so we're going to go that way. First, we're going to find y. Well, to go from the short leg to the hypotenuse, I multiply by 2. So to go the other way, I got to divide by 2. So 30 divided by 2 means y equals 15. And then to go from the short leg to the long leg, I'm just going to multiply by radical 3. So it's 15 radical 3. So let's just do some more examples and see if we can recall what the rules are. So here I've got 2 legs that are the same, so it's an isosceles triangle, 45, 45, 90. So to go from the legs to the hypotenuse, I multiply by radical 2, but going in the other direction, I'm going to divide by radical 2. So x equals 2 radical 2 divided by radical 2. These cancel, so x equals 2. Easy enough. Now I have to find the hypotenuse, so I got to multiply by radical 2. So y equals radical 2, my legs, times radical 2, which is my factor. 2 times radical 2 is radical 4, so y equals 2. Inside with inside, outside with outside. And then we reduce our radicals. So find the missing side lengths. Actually, why don't you pause the video, do this, and then restart, and we'll see how you did. All right, so y is the hypotenuse. They gave us the short leg. Here's the long leg. So times 2, hypotenuse is the short leg times 2. So 2 radical 3 is y. X is going to equal radical 3, which is the short leg, times radical 3, which is radical 9, which equals 3. How'd you do? Great. So here we got to find the missing side, which is h, and this one we got to think about a little bit. So here we have 4, here we have 4, and here we have 4. So this is an equilateral triangle. And this is an altitude because it goes from a vertex, from a side to the vertex at a 90-degree angle, so we can measure the distance from the point to the side. Well, we know that if it's an equilateral triangle, all of these are 60-degree angles. So inside this triangle on this side, we have a 30, 60, 90. The triangle on the other side is a 30, 60, 90. They are similar triangles with a scale factor of 1 because the hypotenuse is the same. The short side is the same in both. So my h is going to be the same in both. Well, h is the long leg of my 30, 60, 90 triangle. So h is going to equal 2 times radical 3 or 2 radical 3. Very simple. But we have to think about what we're dealing with. How are we getting there? We know all the sides are the same. It's equilateral. If it's equilateral, all the angles are the same. They're all 60s. And when I have 60 and 60 here, I got to have 30 left up here. These little ones are 30. That's 30, 60, 90s. They're similar. It's cut in half. Why is that important? Because this example, our biohazard sign is shaped like an equilateral triangle with 36-inch sides. So we got 36 inches here. We got 36 inches here. And we want to find the area, right? The area of the sign. So the area of a triangle is 1/2 base times height. This is my base here. And this is going to be my height here. Well, to find the height, I need an altitude at a right angle. These are 60 degrees and a 90, so I have to have a 30, so it's a 30, 60, 90. They're similar triangles. So that means my h here is going to be 18 radical 3, because each half of this cuts it in half. It's got to be 36 on each side because they're similar triangles. The hypotenuse scale factor is 1. They got to be the same. And then I can use my 30, 60, 90 rule. The long leg is radical 3 times the short leg. So my height is 18 radical 3. So now I can solve. So I get 1/2 of 36 times 18 radical 3. So 1/2 times 36 is 18 times 18 radical 3. So 18 times 18 is 324 times radical 3. And remember, it doesn't matter the order that we multiply in. So we'll take that times, I'll use my calculator. So the area is going to be about 561.2 inches squared. Same exact process, same exact everything. We're not doing anything different. We're just applying our rules and pulling in different information and different equations as we need it. So here we have another equilateral triangle, and we want to estimate the area of the sticker. Go ahead and pause the video, find it, and then restart it to see how you did. All right, so let's find our area. We're starting with our altitude right here. That's going to be our H. We know these are 60 degrees because it's equilateral, so we have 30, 60, 90 triangles. So these have to be 2. These are 4. So H is going to equal the short side times radical 3. So it's 2 radical 3. My area of a triangle is 1/2 base times height. So it's 1/2 4 times 2 radical 3. So 1/2 of 4 is 2 times 2 is 4 radical 3. So this is going to be about 6.9 inches squared. All right, last thing we're going to do for today. So here we have a ramp. It's 80 feet long, and we're going to lift that ramp up so that the stuff comes out of the back of trucks easily, because we didn't buy dump trucks, so we needed another way to empty out our trucks. So we want to know how high is the end of the platform when the angle's at 30 degrees. So what we're going to have is a 30-degree angle, and then that's our height. So we want to find the height at 30 degrees. Well, the length of our ramp's not going to change. And as the edge of the ramp goes up, this is still 80 feet. Well, if it goes up 30 feet, or it goes up by 30 degrees, it's going to go up square to the ground. So that's a right angle. So we have a 30, 60, 90 triangle here. And we know the hypotenuse. And our hypotenuse rule in a 30, 60, 90 is that it is 2 times the short leg, which will be our height. So if I multiply by 2 to get the hypotenuse from the short leg, I got to divide by 2 to get the short leg from the hypotenuse. So it's going to be 40 feet in the air. But this is actually asking me 2 questions. So what happens if I raise it further to a 45-degree angle? Well, still square to the ground, so I have a 45, 40, 90. My ramp's still 80 feet long, So what's my height at 45 degrees? Well, my rule in a 45, 45, 90 is that the legs, or the hypotenuse, is radical 2 times the legs. So to go the other way, I got to divide by radical 2. Well, I can't leave that in the denominator, so I'm going to divide it by 1 with the radicals so that I can get rid of them. So I get 80 radical 2 over radical 4. And I'm going to move this over so I have some room. So I have 80 radical 2. Radical 4 is 2. 80 divided by 2 is 40, so I get 40 radical 2. I'm going to plug that in my calculator. So my height at 45 degrees is about 56.6 feet. And I could have just plugged 80 over radical 2 into my calculator, gotten the exact same answer, but I wanted to show you the process in case we were looking for an exact answer on how to get rid of that radical in the denominator, because leaving it there is a big no-no. All right, thank you for everything. We are done.